As a scientist, I'm very comfortable saying life from dead chemicals, you've got to be joking. It doesn't fit science. The train is going in the opposite direction. And perhaps more importantly, this is a really important question. If life didn't spontaneously occur all by itself, if you need a designer and a planner with an intent, that's a very confronting issue for many people, because if there's a designer, you need to then ask yourself the question, what's my relationship with that designer?
It seems very compelling, but there's so many scientists that would argue against you. Why are so many intelligent people of the opposite view? Life from dead chemicals. You must be joking. Dr. Grocott, that is your stance. You don't believe it. Why not?
That's an excellent question. Let me use an analogy. Look at this table here. It's made of wood and some plastics and a whole bunch of things. They're a collection of chemicals that have been put together. Now, if I take all of those chemicals, stick them in a bucket, stick them in whatever format I want, and I leave them around forever, they are never going to self-assemble into a table, because you need to have a designer and you need to have an intent. What do you want to do with all of this? And it's the same with living organisms. It's not just a matter to have a bunch of dead chemicals, because they're not going to self-assemble into something useful, containing information and having a purpose.
But can I ask, who are you to make these claims?
Well, I've spent my professional career working in chemistry, so I have a PhD in chemistry, and if you want to get really boring and use the long words, it was in the reactions and stereochemistry of octahedral complexes of ruthenium-2 and cobalt-3 containing chiral ditertiary phosphine and arsine ligands. And I only mention that to show that I am a real-world scientist. I've worked for 40 years in industrial research. I've spent hundreds of millions of dollars in research. I'm an adjunct professor in a large secular university. I currently co-supervise postdoctoral researchers and PhD students. I've published scores and scores of papers and patents. So I work as a real-world chemist. I'm experienced as a scientist, and as a scientist, I'm very comfortable saying life from dead chemicals, you've got to be joking. It doesn't fit science.
So, with such an extensive career, why did you want to speak about this today?
It's a couple of reasons. Firstly, I love talking about science. You can probably tell I love talking about science. Bit of a science tragic. I'll use as an example. My wife and I are on a cruise down the Rhine River. Beautiful. She's looking out to the left at the castles and the vineyards and the beautiful natural scenery. I'm looking out to the right to these giant chemical industrial plants, and I know the complex chemistry that's going in there. She says to the left is beauty. I say to the right, look how beautiful that is. So I'm a science tragic. I love talking about science. But secondly, and perhaps more importantly, this is a really important question. If life didn't spontaneously occur all by itself, if you need a designer and a planner with an intent, that's a very confronting issue for many people, because if there's a designer, you need to then ask yourself the question, what's my relationship with that designer? So that's why I'd like to talk about this.
Thanks for watching the interview so far. Just a quick one. If you haven't already, make sure you click that subscribe button so you can see more of this content. Back to the interview.
Now, I know there's a few specific compounds needed for life. Can you tell us a little bit about them?
Yeah, there's a very large number of, when people talk about the natural origin of life, they talk about what they call the building blocks. So there's things called amino acids. Now, many people have heard of them, but most people have heard of proteins and enzymes.
Yeah.
Well, they're primarily made up of amino acids. And then there's things like DNA and RNA, the instruction manual for life. They're made up of nucleotides. And then there's the cell walls, which are made up of what are called phospholipids. They're like fatty acids that you see in some food products. So you've got all of these and many, many other compounds that need to be combined together in a highly structured order to create a living organism. Takes a lot of intelligence. We can't even do it ourselves.
But couldn't eventually these chemicals arrange themselves and create life?
Oh, the actual answer is a very blunt no way, you must be joking. And this is in the realm of science, and I'm talking real science, where you can actually measure what is the probability of two amino acids joining together to form a dipeptide, and then a third one to become a tripeptide, and eventually grown to 60 or a couple of hundred or several hundred to form a protein that has a useful function in a body. So let's start at the first two. The probability of joining the first two together is a function of chemical equilibrium or thermodynamics. You can calculate the probabilities. The probabilities are so vanishingly small to grow in complexity that it just doesn't happen.
Well, it sounds awfully complex, but surely with time all the chemicals could join together.
Again, sorry to disappoint anyone who thinks that. It just doesn't happen because the forces that control whether the molecules will join together are actually all pushing in the opposite direction, or to use an analogy, the train's going in the wrong direction. So I can give you a head start. I can give you a bunch of complex chemicals, not enough for a living organism, but it needs to be grown into something else. If I give you those complex chemicals, they're not going to continue to join. They're actually going to fall apart. The forces are to destruction. The chemical reactions are called hydrolysis, for instance, and water is a contributor to that. So complexity goes to simplicity, not the other way around.
So can you tell me more about those forces?
Yeah. Well, most people are aware that for life, you need to have water. So water is necessary for life, and the astrobiologists or the exobiologists, the people looking for life elsewhere, they look for planets that might have water because water is necessary for life.
Yeah, I mean, we hear it time and time again.
That's right. Yeah, water is essential. Just don't drown in it. But water in the chemistry is actually a weapon of mass destruction. It's a fast-moving weapon of mass destruction. I'll start.
So?
Yeah, I'll start simple. Take two amino acids.
Yep.
You join them together, and you have a dipeptide. But you also produce one more water molecule. Now, there's a chemical principle called Le Chatelier's principle. Nice French name. Very good scientist. The more of this water you have, the more it's pushing the reaction back in the opposite direction. So for those two amino acids which liberated the water, you add more water, and it says, I want to go back. I want to go back the other way. Now, take your alleged primordial soup. What's the main ingredient in a soup?
Water.
Water. So water is an enemy. It's pushing it all in the opposite direction. And that's why these molecules don't join in any order, let alone the right order.
So even if you had all of the right chemicals, the water in your primordial soup or in any other reaction would just wouldn't create the order required for life?
That's right. It won't join. So the order and the joining are two separate things. I'll just touch more on the joining first because you and I are living organisms, and these molecules, these amino acids in our body are joining together, but I've just said the water's an enemy. So how on earth are they joining together in our body? That's because in a living organism, even in a single-cell bacterium, the simplest imaginable first life, you've got these special protective chemicals that hold these two amino acids together. They keep this weapon of mass destruction known as water. They keep it away, and they hold these two together, and then they bring in another one and keep the water away. So you've got all these complex protecting molecules. The trouble is, to produce these complex protecting molecules, you've got to start by joining a bunch of amino acids together, and you don't have the complex protecting molecules. So it's this vicious circular argument. You need all of these big molecules in place to make the simple ones join, but until the simple ones join, you can't get the big ones.
It sounds a bit like the chicken and egg. Who came first?
It is a real chicken and egg. I'll use an analogy. Here's a story. The daughter saved her mother's life before the daughter was born. But unless the daughter has saved the mother's life, the daughter can't be born. That's the daughter who's going to save the mother's life, who, unless her life is saved, the daughter doesn't get born. You see the problem here. The daughter can't save the mother's life because the daughter hasn't been born yet. You've got to have the protective molecule in place to form the protective molecules. So it's a non-logical sequence. It just doesn't happen. You need to have an incredible intelligence to put everything all together all at once to make this happen. And that's what happens in our bodies. It happens in the simplest single cell organism imaginable. You've got this complexity there right from the beginning.
And so how are things ordered?
There's order of sequence, like a sequence of numbers.
Yeah.
You've got to have an order. But you can have a random collection of numbers that becomes meaningless, or you have a random collection of letters that becomes meaningless. You've got to have some meaning in there that can be interpreted. You've got to have a language. You've got to have somebody who can decode it. But let me use amino acids again, or nucleotides. You join them all together, and let's say we're going to make a protein with 200 amino acids. The number of combinations of amino acids from the 20 amino acids in living systems, the number of combinations in randomly forming 200 together is more than the number of atoms in the universe. But only a tiny fraction of those are biologically useful. Most of them is just random noise. And they go from random noise to information. Chemistry doesn't do that. Physics doesn't do it. Time and chance doesn't do it because they're falling apart in the first place.
So what are the characteristics that are needed for life?
So one of my favorite ones, in fact, this goes all the way back to my PhD, and I've worked in this field even quite recently, and that is something called chirality. Now, that's a fancy word for left-handed and right-handed. You know, our hands, we've got a left-handed hand and a right-handed hand, and they're mirror images. Now, that means I can't put my right hand on top of my left hand and have it exactly superimposed. The thumb's not on the thumb, the ring finger's not on the ring finger. Now, most biological molecules come in left-handed or right-handed forms, and you can't mix them up. Now, take amino acids. There are 20 amino acids. 19 of them have a handedness, and they have to be in their left-handed form. One of them is like a thumbless mitten. It doesn't have a handedness. It can go on either hand.
Okay.
But amino acids, they're all left-handed. Now, if I've got a protein with 200 amino acids in it, they've all got to be left-handed. If one of them is right-handed, it doesn't function anymore. It now folds into some sort of demented three-dimensional shape that doesn't serve its purpose, and it doesn't support a living organism.
So it can't live.
Can't live and can't function. And here's the problem, however. If you naturally form these amino acids, they form in 50-50 amounts, roughly 50-50.
Yeah.
And if I'm going to choose out of a bucket of amino acids and I'm going to choose randomly, I'm not going to end up with 200 left-handed ones. It's just something that is statistical beyond the realms of possibility.
But most people would say it really doesn't matter, wouldn't they?
Yeah, a lot of people would say that. So let me use an analogy, because this can be a hard concept. I mean, when I was studying as an undergraduate scientist, this is a hard concept for me to get around. Just, I wasn't aware of it. But let me use an analogy. Now, biological molecules are a bit like a safe and lock mechanism.
Okay.
A big combination lock. We've all seen the movie where you've got the great big safe and you've got the big circular lock where you've got 1 to 100 and you've got to go 23 right and 49 left, and you unlock the lock and you get the treasure. Well, that's the analogy that I'm going to use, and I'm going to add a spin to it, Matt. I've got some very bad news for you. You've just taken a fatal poison. Sorry about that. But don't worry, the antidote's in the safe.
Okay.
And I'm going to give you the 10 numbers you need for this safe to unlock it.
Perfect.
10 numbers. It's 1, 11, 22, all the way through to 99. They're the numbers. There they are, Matt. Now, you should ask me one question.
Which way do I turn?
Yeah. Do I turn those 10 numbers left or right, and what's the order? And I'm such a nice guy, Matt. I'm going to say, well, the first 9, they're all left-handed. Turn them left-handed. But you have to guess the 10th one. You've got 10 seconds. Off you go. Now, you're very lucky. You get to the 10th one. You turn it left. The safe opens. If you turned it right, the safe doesn't open. Biological molecules are just the same way. You've got to get all of you've got to get the numbers in the right order, and you've got to get the left, right correct, because if you get a right-handed one in there when you need a left, the biological molecule doesn't work. So not only do you die, but you never even existed in the first place, because life doesn't come about unless you control that specific complexity.
So everything has to join well and without any mistakes.
You cannot afford any mistakes. There are some proteins and enzymes where you can tolerate a little bit of right-handed in with a left-handed, or with sugars which are right-handed, you could tolerate a little bit of left-handed in with the right-handed. But by a little, I mean like 1 in 1,000, and it's actually degrading in the effectiveness of the function of that biological molecule, and a degrading in our life. And you can get mutations which cause this loss of specific complexity, this loss of information. But it is a very, very narrow tolerance. And statistically, it's so impossible as to be speculation beyond the wildest imagination of a rational scientist.
But couldn't that cause an evolutionary change?
So what is evolution? So evolution, most people get it mixed up. Evolution is actually a process in which there is a supposedly a gain of information. But remember these destructive forces, the forces of water, which cause the complex molecules to fall apart, for cross reactions to occur. These forces actually degrade the information, they degrade the complexity. So evolution, it does not occur. Most people mix it up with something called natural selection, which is selecting from a pool of information. That's real. That's been known for a long time. Ask any farmer when they breed, that's all they're doing. That's unnatural selection, because they're choosing what offspring they want to procreate.
Yeah, always looking for the best traits.
Yeah, always looking for the best. Now, nature in science and chemistry and physics doesn't work that way. Complexity goes the other way. It's a degrading. Evolution is supposedly a process where information was added by mutation, but it doesn't. It causes a loss of information. Like these 200 amino acids. I turn one of them from a left-handed to a right-handed. That's a loss of information, and it's a loss of function.
But again, couldn't time give this process chance?
And you remember I said that water is a weapon of mass destruction. Time is also a weapon of mass destruction. And there's a cute analogy used by some people who believe in the spontaneous origin of life. Mm-hmm. They fill a room full of monkeys with typewriters, and they're hammering away. They've taught them to bang on the keyboard. Yeah. And if you leave it with enough time, you'll eventually type, complete works of William Shakespeare or the 23rd Psalm or something like that. Over time, surely you will get there. Now, statistically, you can calculate that, and it's actually much less than 1 in the number of atoms in the universe. But set that aside. It's actually a false analogy. In such a deceptive analogy, I call it, at best, lazy and ignorant, but it's actually quite deceptive.
Okay, so explain to us how the analogy is wrong then.
So, take these amino acids. One joins to another. That's the theory of the origin of life, and then another, and another, and another. So that's the monkey analogy. I type, bang, bang, bang. All the letters stay there on the paper, and eventually I assemble something. Wrong analogy, because remember these amino acids, once you've joined them, they want to fall apart. So the real analogy for the typewriter is when the hairy monkey bangs down on the keyboard and a letter appears on there, and there's a collection of letters, the letters are also disappearing.
Why?
Because the forces of thermodynamics, the forces of water, are disintegrating or hydrolyzing these molecules. So the real analogy is, as a letter gets banged down there, letters are dropping off. So this chain of amino acids, or this chain of letters, is not going to assemble into a functional protein, and the chain of letters are not going to assemble into the 23rd Psalm because the letters are disappearing.
So someone's just sitting there with an eraser.
That's right. They've got there and they're blotting out the letters, or they're removing the letters from, they're cutting them out, or they're scribbling on them and changing them, or they're jumbling things. So all of the forces are heading in the wrong direction. So the monkey analogy is actually a very poor analogy that was invented or created by some people who really wanted to deny the existence of an intelligent designer. It's a very poor analogy. So I encourage anyone who's watching this, go back and check, is that analogy that is used valid for the chemistry and the science that occurs, that is known science?
If you're enjoying this interview so far, you might be interested to know that we also produce the world's most widely read magazine on the creation-evolution debate, Creation Magazine. It's packed with beautifully illustrated articles showing how real science supports the Bible. It's designed for the whole family and is a great tool for strengthening your faith. Sign up now to receive 4 issues per year. Follow the link in the description.
So before we move on, do you have any other comments about the origins of life?
Yeah, I guess what I'd like to say is in everything I've said so far, I've actually been a raging optimist in favour of spontaneous origin of life. I mean, I've been stacking everything in their favour. I haven't even talked about all of the forces that rail against the spontaneous origin of life.
Yeah.
For instance, take temperature. Some of these so-called precursor molecules that have to combine can only occur in a narrow temperature range. So for the proteins occur in this range, and for the sugars it occurs in that range. Now those temperature ranges are different for each of them. You need a Goldilocks range for this one, but the Goldilocks range for this one is actually the too hot or too cold for this one. So temperature, you can't get everything all together all at once. And then there's pH. People know what pH is, the pH in their swimming pool or the pH in their mineral water. So pH has a Goldilocks range for each of these two. But unfortunately, the Goldilocks range for each of them, they don't overlap. So they're in conflict with each other. Then you have to get all of these together in the same place at the same time. So that is a very difficult thing to do, even in a laboratory. If you want them all together at the same place at the same time, they now have to be there at a sufficient concentration. To build up that concentration, remember the monkeys and the letters, they're disintegrating. So you can't actually build up the concentration that you need all in the same place at the same time. And then you've got something called cross reactions. So you've got amino acids which have to combine to make proteins. You've got sugars that have to combine to make polysaccharides. But guess what? The amino acid would rather react with the sugar than with another amino acid. So you get these cross reactions that are not biological molecules. They destroy the concept of a spontaneous origin of life. And I could go on and on and on. There are so many factors that people really just speculate about, deny the creator and say, well, it must have happened. But science does not support this. It's actually very, very strong science which says this doesn't happen by itself.
It seems very compelling, but there's so many scientists that would argue against you. Why are so many intelligent people of the opposite view?
I'm glad you raised that. The people who don't agree with this, they're not dumb. I mean, I didn't used to believe in this as well. Maybe people think I'm dumb, maybe they think I'm intelligent. But the people who don't believe this, they're not dumb. It's not a matter of intelligence. There are plenty of intelligent people who don't believe what I'm talking about. But this is where you need to distinguish between a scientific opinion and the opinion of a scientist.
What do you mean by that? Sorry.
So a scientific opinion is founded on science. And what is science? Science is something which is falsifiable, it's testable, it's observable, and it's repeatable. An opinion of a scientist is just that. A scientist has an opinion. A footballer has an opinion. A film producer has an opinion. These are opinions that people have. So there's a difference between a scientific opinion, which is based upon science, and an opinion of scientists. Now, a lot of scientists have the opinion that life arose by chance, but that is not an opinion that is based upon science.
So why do so many scientists believe in the spontaneous origins of life over a creator?
For the same reason that a non-scientist believes in it. And I'm an expert in this because that's where I was. Okay. Why didn't I believe in a designer, a divine origin of life? Why did I believe in a spontaneous origin of life? A number of reasons. Firstly, I'll talk about specialization, and that's especially the case as knowledge in science has grown and grown and grown. People have become more and more specialized and narrower in their expertise, usually speaking. So if you asked me as a chemist, where is the evidence for the spontaneous origin of life? I would say, well, you've got to go to the astrobiologists. And you go to the astrobiologists and they would say, well, you've got to go to the statistical physicists. You've got to go to, and you go to them and they say, no, so it's passing the buck around. So specialization is one reason why people think that there's an answer out there somewhere that's just not in my field.
So that's one reason. Are there more reasons?
Yeah, there's some more fundamental reasons. So in my case, and in the case of many people, scientists and non-scientists, is they don't like the answer. If you say, Matt, clearly life did not arise by chance. So there was a designer. And many people don't like that answer. They don't like there to be a designer because they want to be in charge themselves. So scientists want to elevate science to a platform where it's got the answers for everything.
In control.
When it doesn't. People like me, I didn't want there to be a designer. I wanted to be my own boss. I wanted to be in charge of my own destiny. I thought I was doing okay. But many people may think, well, no, scientists are objective. No. There are some very famous evolutionary scientists who have said, we cannot allow a divine foot in the door. Now, why would a scientist make a statement like that? That's got nothing to do with science. That's not a scientific opinion. That's an opinion of a scientist. Why can't you allow a divine foot in the door? Well, because there is no God. What's your evidence for there is no God? Well, life arose by chance. How do you know that life arose by chance? Well, it must have arisen by chance because there is no God. So it's a circular argument, and it's opinions because people don't like the implications. I didn't like the implications.
But I thought it was necessary to exclude God and religious views from science.
No, science is very simple. Well, it's very clean in its definition. Falsifiable, repeatable, observable, it's testable. There's nothing in there about divine intervention. So science is science. Belief about origins is outside of science because it's not observable to human beings. It's not repeatable. We can't do it. It's not testable. Now, you can use science to evaluate the implications of a divine origin or a spontaneous origin. And spontaneous origin does not stack up very well because we know that complex information doesn't arise by chance, whereas science does support the fact that there is a divine origin to life.
Well, thanks so much for sharing. Did you have any other views that you wanted to share before we closed?
Perhaps I'll just go back to when I was doing my PhD. There was a PhD student in my laboratory. He was a bit more senior to me. He was a believer in a young earth and a recent creation and a divine origin to life. And he was a strong Christian in his belief. And he made that very clear to all of the other PhD students in the laboratory. And he used to present the scientific evidence for non-spontaneous origin of life. And I used to see the ridicule and the mockery that he used to get. All of it was based upon attacking him as a person. Not once in the years of my PhD did I see a single person on a single occasion critique his science. And it's because it couldn't be critiqued. It was waterproof. So it was all because he was different and they didn't like the implications and they felt uncomfortable. Now, I was a bit guilty of that too. So that made me think, why are we attacking this guy as a person as opposed to the science, which is what he's talking about? So it was a pretty obvious conclusion. It's because the science was pretty compelling that he was talking about, and we just didn't like the fact that he was highlighting that there's perhaps a responsibility that we have to a creator.
You've told us how life didn't occur. how it didn't start, but how did it?
So the way to answer that is to understand design. So here's an analogy. I'm walking along a beach and I see written in the sand, "I love you, Stephen." And I think, as a logical scientist, no creator, no information source, and I think 15 million grains of sand, a remarkable coincidence what the wind and waves have done. No, I don't think that, do I? I go, that's information. I remember. My wife was walking a half a mile ahead of me and she said, "I'll meet you in the beach cafe." And I go, now I know where that came from. It's the same for the spontaneous origin of life. Rule it out. You see information. Where did this information come from? What do I see in life? I see a power, an intellect, a force that far outweighs anything that I can comprehend. And I see a purpose in life. I see a reason in life. I see a beauty in life. All of these things are not products of evolution. These are products of a loving, caring, purposeful, intentful designer. And I wanted to learn more about that. And I encourage people to do the same.
Yeah, that's fantastic. I know one of the ways that I was greatly encouraged in some of the science behind a divine creator was the product that we're listing today, which is evolution's Achilles heel.
Yeah, that's if you're a book reader, it's a fantastic book. There are 8 great chapters in there. If you're visual, there's a DVD or a video you can download that it's got 8 chapters about the Achilles heels to evolution. But just as we were talking about, it goes further than that. It talks about the intent behind design. In my favorite chapter in there as a chemist is in chapter 3, which is written by a fantastic scientist, Jonathan Sarfati, where he talks about all of the chemistry and the physics behind the origin of life and dispenses completely with the idea, the false concept that it arose by chance, and explains how it happened in a purposeful, intentful manner. And I know that Creation Ministries are going to make that resource available as a free stream.
Yeah, and we'll make sure that we put the link in the description. Thanks so much for speaking with us, Stephen.
Thank you, Matt. I've enjoyed it.